Alright, these factorizations are, some extra ones, some fractions, so a little bit harder than your other ones. So basic ones first. If you were someone who struggled with the first 3 pages, focus on those first. Maybe Google some more examples. Try Google and then try some more examples. These are obviously kind of the more of the extended ones we will focus on. Okay, so the first one, we need to factorize this. So obviously my first step is to make one side 0. So it's going to be minus 28 both sides. And when I write it, I'm going to make sure I write it in the order that I want to work with. So x squared term first, and then the x term, and then the constant term equals 0. So technically I don't need that. So this is what I'm working with. Just going down my list, can I have common factors? Nope. Can I do difference of 2 squares? Nope, don't have 2 terms. Can I use perfect squares? Nope, this is not square rootable. Can I do sum and product? I probably could, so let's try. So this is my sum. Oh, no it's not. This is my sum. This is my product. Okay, I'm aiming for minus 28. I'm aiming for 3. I'll just write that down so it's clear. So 7 times 4, 1 times 28, 2 times 14. I think that's about it. And I need to make sure one of them is a minus because I have a minus option. So when I add and subtract these, I need to aim for 3. I'm thinking 7 and 4. So if I go maybe, I'm aiming for positive 3. So if I go 7, take 4, I should get a positive 3. Happy with that? So these are my 2 terms, and I just have to factorize it. X plus 7 for that option. X minus 4 for that option. Done. So all I need to do is just solve these. They are null factor laws. So a can be 0, this is a, this is b. A can be 0, meaning x plus 7 can be 0, or b can be 0, so x take 4 equals 0. So if I solve these, therefore x equals minus 7, surely you can just do that, that's not too hard, and or 4. There you go. Alright, let's do the next one. When there is a fraction, you need to cross multiply. Whenever there's a fraction, you cross multiply. So that means cross multiply. Diagonals, you times. So I'm going to do one diagonal at a time. Let's do this diagonal. I times all of these together, basically. So 2 bracket x minus 2. I'll just write it first and we'll work it out later. Equals the next diagonal. So here we go. X bracket 6 plus x. So I need to expand it. 2x minus 4. 6x plus x squared, and I need to make sure everything is on one side, so I'm going to make everything go on this side because I like to have x squared as a positive number. If I put everything on this side, I will have to minus x squared, and that means I get a minus x squared, which I do not like. So I'm going to do plus 4 to get rid of it from this side, and then minus 2x because there's actually a plus there. So everything's on the right hand side now, so it's going to be x squared. I'm going to write it in the highest order, so x squared term goes first, and then I figure out what 6x take 2x is, which is 4x, and then I got a plus 4 on this side. So this is what I'm trying to factorize. Let's go down my list. Can I use common factors? No. Can I use difference of 2 squares? No, there's no 2 terms. Can I use perfect squares? Might be able to. This is square rootable, this is square rootable, so let's have a go. So if I write the pattern, it's the plus option. Let's see if it satisfies. So my a and b I should be able to find. A can be x, b can be 2. Let's just make sure 2ab is going to be 4x. This is what we're aiming for. So 2 bracket a bracket b, definitely 4x. Happy with that? So that means my answer is going to be looking like a plus b, a minus b, because that's how you factorize a squared take b squared. Nope, that is not what we're doing. What am I doing? So we are factorizing a squared plus 2ab plus b squared. So that factorizes to a plus b squared. That's what we're aiming for. X plus 2 squared. Oh, that's a bit better. Oh, and now we have to solve it. So that means that equals 0. So one step further. That bracket, that whole bracket, x plus 2, it's getting a bit messy. X plus 2 equals 0. So that means x equals minus 2. Squared means there's 2 options. So it's going to be minus 2 twice. You can write it like that or just write it once. If you write it both, I just know that you know that it's going twice. Okay, this is a harder version as well. 2 fractions on one side. I need to make sure I add them first before I'm able to cross multiply with the right hand side. So basically, what you need to do is add these together. How do you add them? You need to make sure the denominator is the same, meaning you need to find the lowest common multiple. Easiest way to do it, if it's not numbers, is just times them together. So my new factor, my new denominator I am aiming for is this whole thing. You just times them together. So because that was my factor and I times it by x plus 6, I need to make sure I times this new term up here, numerator, by x plus 6. So it's going to be x plus 6. I'm just going to write a bracket around there. And then the second one, I need to make sure I times this one by x. So I need to times this by x. So it's going to get 4x equals 1. I'm just going to write equals 1 there for now. Alright, so now that the denominator is the same, you can add them together. You can add the numerators. The denominator stays. You can add the numerators. So it'll be 4x, or I can write it in order, x plus 6 plus 4x equals 1. Alright, let's keep simplifying. I can add these two together because they're like terms. So therefore, 5x plus 6 divided by x bracket x plus 6 equals 1. Now 1 can be written as a fraction by just dividing 1. Any number can be turned into a fraction by dividing 1. Now we are at a fraction equals a fraction. We cross multiply. These are 1s, so it's really easy. I always like to put extra brackets on there for safety. So this diagonal, if I times them together, it's just times them by 1. So therefore 5x plus 6 is all I have on the left hand side. And the next diagonal, if I times those two diagonals together, again timesing by 1, so easy, x, just copying it down, and then I just have to make sure I expand. Okay, so 5x plus 6 equals x squared plus 6x. Make sure they're all on one side. Again, this is a positive, so I'm going to make sure I bring everything on this side. In order to do that, I've got to do minus 6 and then minus 5x. And then I just want to write it in one simple long answer. So therefore 0 equals x squared plus 6x. Take 5x, so plus x minus 6 equals 0. Oh my goodness, we're almost there. We already have it equals 0. So this is what I'm trying to solve. I need to factorize it. How are we going to do it? Let's go down the list. Common factors, there's none. Difference of two squares can't work because it's more than two terms. Perfect squares, 6 is not square rootable, so it can't work. So I'm going to try products, sum and products. So product, sum. Number is 1, number is minus 6. So I need to write all my products, 2 times 3, 6 times 1. I think that's it. So what two numbers, I need to make sure one of them is a minus because that's a minus. What two numbers can I add and subtract to get 1? Well, obviously it's going to be 3 take 2, 1. So those are my two factors. Right, this is a lot of information here. So therefore, I'm going to write over here. Therefore, my two factors is going to be x plus 3, x minus 2 equals 0. Now using null factor law, both of these terms can be equal to 0. So x plus 3 equals 0 or x minus 2 equals 0. So therefore, x is going to be minus 3 or positive 2. This is the kind of quick maths I did in my head. Now, something you might want to notice is these linear factors. So if it's a plus 3, your answer is going to be minus 3. If it's a minus 2, it's going to be a plus 2. As long as, this looks like x and x. If it's a minus, you might have to look at it a little bit differently. Okay, last question. Completing the square. For each equation, what number must be added to both sides to complete a perfect square on the left-hand side? Now, this we will learn a little bit more in detail in Year 11 content, so don't stress. Just at least listen and write it down if you don't completely understand it. So we need to basically complete the square. And what we want to do is, once we write this, the x squared term and the x term, we want to leave a little bit of space and then copy the right-hand side. The first step is to making sure the constant term is on the right-hand side. We want the x squared term, x term on the left-hand side, constant term on the right-hand side. Second step, and we will go through this again, so I'm just going to get you to write it down at least. It might spark your memory. We did learn this in Year 10. Second step is for you to write plus, okay? And then you need to add the coefficient divided by 2 and then square it. That is just what you need to add in order to be able to make perfect squares. completing the squares. So now this we've just randomly added. So you need to make sure you add on the other side in order to balance this equation. Okay, so now that we do this, this is a perfect square. So what that means is if I write it nicely and figure out 8 divided by 2 is 4, so it's 4 squared. Okay, I could definitely use a calculator for this. Probably a smarter idea than trying to use my brain on a Thursday after a sports day. I'll try my best. Okay, this is what we're working with. This is a perfect square pattern. The rule is we purposely divided it by 2, this coefficient, and then squared it in order to make it perfect square all the time. So I don't even have to check it. I know that, let me highlight it. This is my A and this is my B as long as it has a squared answer to it. So I know that this is going to be the same answer, just in a factorized form. So these are the same. All of this gets factorized using the perfect squares into that. You can try that out yourself if you don't believe me, but it is. Now I just got to figure out what that is. In order to add that into fractions, I just need to make sure the denominator is the same. So I times 4 here, times 4 here, minus 20. Alrighty, so minus 20 plus 64 is going to give me 44 over 4. Oh my goodness, almost there. So actually, I technically answered I. I'll talk to you about that in a second. 11. Okay, we're getting somewhere now. This is my, where I want to be. I want a square, and I want a constant term on the right-hand side. So, in order to answer I, it says what number must be added in order to complete a perfect square. So the answer for that, we've actually kind of answered it already, is, what am I going to highlight it with? This one. It's going to be this answer. So this is actually the answer for I. What number must be added to both sides to complete the perfect square? So that is 4 squared, which is 16. So answer for AI is 16. We added 16 to both sides. And then we need to hence write the equation in completed square form. We have done that. We have completed the square and written it. And that is the answer for the first one. All you have to do is repeat it for the second one. So I'm going to write it. I'm going to go through it. So that means I need to just write x squared minus 6x, leave a bit of space, and write 13. And then what I'm going to do is add this coefficient, so minus 6 divided by 2, and then square it. So again, balancing the equation, and then that is going to be my answer to I. So BI, my answer is whatever that is. If I figure that out, minus 6 divided by 2 is minus 3, minus 3 squared is 9. So 9 is the answer for my I. And then I'm just going to continue on with my answer again. So what I'm saying is your A is going to be the X, your B is going to be that number minus 6 divided by 2, which is 3. So it just simplifies down to X and then a minus 3 squared. So this one's a minus because minus 6 divided by 2 is minus 3. So that just literally whatever's in that bracket just goes in there, and then the X goes in there. Now I just got to figure out this one. Great. 13 plus minus 6 squared is 36. 2 squared is 4. And I just need to add that together. So 4 times numerator, denominator by 4. 52, I think. There might be some errors in here just because I'm using my brain. But of course, you can use your calculator. 88 divided by 4. Alright, I'm hoping that is the answer. Okay, so that's really it. So I just got to write 88 divided by 4, 22, and that is hopefully the final answer. I might just quickly check the answers for these ones so I can edit it quickly if I did it wrong, but hopefully they are correct. Where are we up to? So year 10 revision, completing the square. Which ones did we do? I think it was the first 2 examples, the easier ones. I reckon we got it right. X plus 4 squared equals 11. Yep. And then X, where did it go? Damn it. I lost it. X take 3 squared equals 22. Yes, we got it right. That's it.